We're talking about linear programming, and you want to graph a system of linear inequalities to find the solution of a system, solve linear programming problems, and use system of linear inequalities in linear programming to solve real-life problems. So we have a real-world application. Craft toy wagons are made to sell at a craft fair. It takes 4 hours to make a small wagon and 6 hours to make a large wagon. The owner of the craft booth will make a profit of $12 for a small wagon and $20 for a large wagon. The craft booth owner has no more than 60 hours available to make wagons and wants to have at least 6 small wagons to sell. How many of each size should be made to maximize the profit? So we have some constraints there. That's the first thing we have to look at. So what are the constraints? So has to make at least six small wagons. So if we do S and L, so S has to be greater than or equal to 6. The craft booth owner has no more than 60 hours available to make wagons, so no more. So 60 hours is the most. But it takes 4 hours to make a small wagon and 6 hours to make a large wagon. So 4 times S plus 6 times L, that will be the total hours. But the craft booth owner has no more than 60 hours, no more than. So could be equal to, but it has to be less than 60 hours. And then the last one, the large wagon, doesn't necessarily say, but in this case, the large wagon has to be greater than or equal to 0, because you can't make less than 0 large wagons. So if we say that this axis, the x-axis is the small wagons, and the y-axis is the large wagons. Again, we don't have to pay attention to the negative side because we're dealing with positive integers here. And we go to graph this. The one we should check out probably is 4s plus 6l is less than or equal to 60. So if s was 0, L would have to be 10. So 2, 4, 6, 8, 10. So we'll at least have to count by 2's. But if 6 was 0, then 14, or then that'd have to be 15. So 2, 4, 6, 8, 10, 12, 14. Doesn't quite get us to 15, so we're going to have to count by 3's. So 3, 6, 9, 12, 15, 18, and the same thing. 6, 12, 18. So S has to be greater than or equal to 6. So the small wagons have to go to 6. And so that one is going to be right here, this line. So that is S is greater than or equal to 6. The next one that we can look at is L is greater than or equal to 0. and that is just going to be this one right here. L is greater than or equal to 0. That's that line. S is greater than or equal to 6. So we're here, and we're here, and we got this one last restraint that we have to graph. So if S was 0, that drops out, so then L has to be 10. So S is 0, L has to be 10, which is just a little bit above there. And if L were 0, then S would have to be 15, which is right there. We can draw the line that connects those. And then we have our feasible region is that shaded region in between there. So that's our feasible region right there. And then we have to look at what our ordered pairs are. So we have, right here we have 15, 0. Here we have 6, 6. And here we have 0, 6. Or excuse me, 0. So if we're looking to maximize profit, we can look at it right now, and we can say that selling 6 small wagons and 0 large wagons is not going to be the same profit as selling 6 large wagons and 6 small wagons. So we know that this is going to be the minimum, but we should still check to see what the profit would be for that one anyway. So we have to have our objective function. And our objective function, we're talking about the profit, and we're selling small and large wagons. Small and large wagons, and we make $12 for a small wagon, $12 times all the small wagons, and we make $20 for the large wagons. And then we just have to check our 3 vertices. We're trying to check for the profit for our 3 vertices. And our 3 vertices that we have to check are 6, 0, 6, 6, and 15, 0. So we can substitute those in. So 12, and then we can substitute in our values that we have, which is 6 and 0, and 6 times 12 is 72. So our profit for selling 6 small wagons is $72. Then we can check 6, 6, which is 12 plus 20, and we already know that it's going to be more because we have the same number of small wagons, but then we have an additional 6 large wagons. So in this case, we're going to end up with 192. And for the last one, 15 small wagons and 0 large wagons. So plug it in, $12 per small wagon, $20 for the large wagons. We didn't sell any large wagons, so we made $0 from the large wagons, but we sold 15 small wagons, And so in this case, we make $180. So after we have it graphed and we check the vertices, then we know that the most that we can make is $192 would be the max. And the craft booth owner should make 6 small wagons and 6 large wagons to maximize profit of $192. So the craft booth owner should make 6 small wagons and 6 large wagons to maximize profit potential 2 times spent building.